This is fundamentals test 3. Let's see what how all you guys did. Now, if somebody got the question wrong, mark it wrong. If they did it with a pencil, don't erase their answer and change it to the right answer, even if you like the person. All right. And these are fairly simple. These are sort of opener questions for hazardous materials. What is not a hazardous material amongst brake cleaner, engine oil, asbestos, or water?
Water.
Now, water is also known on some of the websites you may look up as dihydrogen monoxide. And they talk about it being really bad because it can kill you and corrodes metal and all this kind of stuff. And it's a joke, really, because dihydrogen monoxide, you got 2 molecules of oxygen, one of, or hydrogen, 2 of hydrogen, 1 of oxygen, H2O. And they call it dihydrogen monoxide, just as a joke. To determine if a product or substance is being used as hazardous, and where are you supposed to look?
Hey,
MSD, that's material, safety data sheets is what that is. And what that amounts to is what a MSDS is, and we've got some out here in a box, but every chemical that you use in a shop environment has got an MSDS sheet that's been published for it. And the reason it's there is so that if you happen to swallow some of it or splatter a bunch of it in your nose and your eyes and all that kind of thing, you need to know medically what to do. Like, for example, there are some things, if you swallow them, you're supposed to throw up to get it out of your system. There's some things, if you swallow them, you're not supposed to throw up. Okay, so you're basically, there's treatment options and all that basically says this is what this will cause if you swallow this, redness of the eyes, inflamed nasal passages, and or it'll cause death, or so on and so forth. So you basically have to know about that, and that'd be for carburetor cleaner, brake fluid, any of the chemical in the safety clean parts washer back there. All of that stuff has material safety data sheets. And that's what an MSDS is all about. So number 2 should be C. If you didn't put C, mark that wrong and slap yourself. Okay. Now, exposure to asbestos dust can cause what?
All of the above.
Yeah, asbestosis, lung cancer, mesothelioma, which you see those commercials all the time. And basically, when it mixes these answers around, it may put all of the above as B. That's just the way the test software runs and all that. But if you're doing rear brakes and you're going to take the brake drum off and you find dust all over those brake shoes, don't blow it off with air. I was in here one time right after I started teaching, and I was telling the guys that there was 12 people in here. These were college students. And I said, don't blow the brake dust. We got to use they're wet. It's something wet. I don't care if you hose it down with 409 and then rinse it off with water. You just got to get something wet on it so the dust can't fly. And so as soon as I got through giving that class session, we went out there in the shop and we jacked up a car, pulled the brake drums off, and went whoosh with the blower. Just like I told them not to do. I don't know why some people do that. This one guy I had in here one time, I was saying, when I first put that battery on that hand truck, I said, okay, now you recognize that this is these two jumper cables coming off this battery. If you touch them together, they'll spark. He goes, yeah. And I said, okay, so what you don't need to do is take both of these jumper cable clips and hook into this metal part of this, you know what I mean? And he was saying, okay. And he was looking at me, nodding his head, and as soon as I stepped back, he hooked them both to the metal thing. And the same guy, I says, you don't take the dirty transmission oil line on the transmission flush machine, and the dirty oil that goes in the waste, it does not go back in the clean oil tank. You understand that? Yeah. First thing he did was put the dirty oil in the clean oil tank and push it empty waste. I don't know what he was thinking, because he was looking at me nodding his head, but he couldn't hear what I was saying for some reason or another. An oil filter should be hot drained for how long before disposing of the filter? That's number 5. I would have put, one of my possible answers, if I'd have written this test, I would have put until it gets cool, right? Because it's not going to be hot drained for 4 hours. It's going to be cool pretty quick. Actually, it's supposed to be, hot drained. Well, it's supposed to be, that's number 5 you're talking about. It says 12 hours, but that's according to the book. According to the Alabama environmental people, the guy that comes around with the hard hat and the clipboard to make sure we're covering all the territory, he said 24 hours. But we get by that. How do we get past that here? We don't hot drain anything. We have a drum that Safety Clean brings. It's just for oil filters. And when we get through changing oil, we throw all the oil filters in that drum. And when that drum is full, the safety clean guy charges us $100 and he hauls all those oil filters away. So basically the oil that drains out of the filters is contained in that drum, and that's how we do that. So you gotta be EPA compliant on all that stuff. Number 6, used engine oil should be disposed of by all these methods except for what? It should A, shipped off site for recycling, B, burned on site in a waste oil approved heater, C, burned off site in a waste oil approved heater, D, disposed of in regular trash.
Indeed.
Yeah, D is the one you're not supposed to do. Now, a waste oil heater works really well. I don't know if you've ever seen one of those or not. But you know these stove pipes that you see like you come out of a wood heater with? You know what I'm talking about? They make one that has stove pipes going this way. Back and forth, back and forth, back and forth. And when you burn the waste oil in the bottom of that thing, those pipes get really hot. Boy, they'll heat the shop up really good. Now, we hadn't used one of those here because we've got some really nice infrared heaters, but some shops use that. And that way they're getting rid of their waste oil, plus they're providing heat. They're using the energy, see. What do they do with the oil they haul away, by the way? When they come and suck it out of there and haul it away, what do they do with it?
Recycle it.
And they recycle it.
Yeah, they run it and recycle it. How? What do we think they do when they recycle it? Well, they're basically going to purify it and use it for other things, you know, whatever. The thread pitch of a bolt is measured in what units? Millimeters, threads per inch, fractions of an inch?
I put D, both A and B.
Both A and B are correct. If you've got a standard bolt, like this one right here is 5/16 US standard, and you're basically measuring how many threads there are in an inch. And that's about an inch. They got those threaded usually about an inch. Have you ever noticed a lot of the time metric bolts will have threads all the way? You know, but not every time, but a lot of the time they will. And standard bolts will just be threaded about this far usually, unless it's a specialty bolt. Well, the point is, how many times do you have to turn it for that bolt to go an inch? Is how an English bolt is done. Okay, so you've got a metric bolt, and it's going to be how far it is from one thread to the next. And so if you've got 1.0, what does that mean? 1 millimeter from the peak of one thread to the next. So every time you do a full turn, that is going to run 1 millimeter. So, all right, let me ask you this. Let's say I'm working on a Perkins diesel forklift, and those are built in the United Kingdom. You know what the United Kingdom is, right? Mm-hmm. England, Scotland, Ireland, where my roots are. But anyway, I got to decide which set of wrenches I'm going to pick up with before I go out here and open the hood on this forklift and start working on this Perkins diesel engine. Okay, so I'm going to open my metric tool drawer, or am I going to open the other one?
Metric.
Metric.
Why?
Because it's not
They use the
made
metric.
Where did we get inches and feet? From England. Inches and feet. You're gonna, if you're working on a Perkins diesel engine from England, you're gonna use a 9/16 and a 3/8. Isn't that something? That surprises you, wasn't it? Well, I did a lot of work on Perkins engines when I was down there at that offshore services company doing all that stuff. But anyway, I was out there one day. I was doing fleet maintenance, and what that means is I was responsible for maintaining about 40 cars, trucks, forklifts, pipe loaders, this kind of thing. Mostly, about 17 forklifts, probably about that many cars and trucks, and 3 pipe loaders, and I also helped work on the cranes. I did not help work on the helicopters because I didn't have an A&P license, but as I watched those people working on those helicopters, I figured it was the last thing I wanted to do. And I went in there and they had a doggone rotor blade laid across those padded sawhorses, and on those days they had a rubber strip on the leading edge of the rotor blade so that it was whirling in the air and it hit bugs and stuff, it wouldn't damage the rotor blade. And ever so often they'd have to get that rubber off of there and replace it. And so they had this methyl ethyl ketone, and they were cleaning off the surface that this rubber on the edge of this rotor blade was supposed to go on. And I said, that looks about clean enough to me. Of course, I'm thinking about gaskets and stuff. You know? They said, oh no, this has got to be really, really clean. And they were working on it. So I just walked off the airfield because I was there to look at something else. And when I came back about 2 days later, these guys I said, well, how many rotor blades have you done? And they said, this is the one we were working on when you were here What? You've been working on the same rotor blade for 3 days? Man, give me an impact wrench. I want to make something happen. You know what I'm saying? I mean, this business about polishing the place where the rubber goes for 3 days didn't appeal to me at all. But anyway, let me see. Technician A says the diameter of a bolt is the same as the, hey, Timmy.
I'm going to leave my key in here and just call me when you finish.
Okay, I will. Technician A says the diameter of a bolt is the same as the wrench size used to remove or install the fastener. Technician B says the length is measured from the top of the head of the bolt to the end of the bolt. Who's right about that? Either one of them. You're gonna measure it from just underneath the head to the tip of it, aren't you? And that's, let me see, that was number 8. That's gonna be D, neither one of those guys are right. The grade of a fastener, such as a bolt, is the measure of its what? This is a grade 5. Got 3 notches on top of it, so it's grade 5, huh?
I put A.
Okay, A, it's actually tensile strength. What is tensile strength?
That is, A is
Sorry.
tensile strength.
I mean, what is tensile strength?
How much the bolt can withstand?
To stretch. Now, there's something else, how much shearing force it can stand. And one time I took a bolt of this nature, because when I was putting my leaf springs back together on my truck, and I just had a bolt in my toolbox, and when I put it in there and tightened it up, I didn't realize that it wasn't strong enough to take that shearing pressure, and I was driving along on my 74 Ford pickup, this was like back in 1978, and I hit a bump, and it sheared that bolt, and the axle got crooked under the truck, and suddenly I was dog tracking down the road, sort of sideways. Now, if it comes back far enough, the drive shaft comes out, and then you got big trouble, you know what I mean? But that was something that happened, but that, you gotta make sure that you use a bolt that's strong enough for the application that you're using it for. That's really important too. Okay, the grade of a fastener is a measure of tensile strength, which is A. Which of the following is a metric bolt? 5/16 18, half 20, 8 millimeter, M12 by 1.5.
C.
Which one?
C.
C. 8 millimeter.
Well, what's wrong with M12 by 1.5? That should be, if you're talking about a bolt, M12 by 1.5 tells you everything you need to know. 8 millimeter would be a wrench size, right?
Yep.
So basically M12 by 1.5. Well, that's metric 12 by 1.5 thread pitch. Although most metric 12 bolts are 175 thread pitch, unless you're, looking at. But remember, the smaller the thread pitch number on metric now, you remember is a finer thread. See what I'm saying? Now, you also got something else you got to recognize. I've said this before. I said this when y'all are doing your bolt sizing exercise. If you have to pick up the phone and you have to call somebody at the part store, and let's say they're delivering the bolts and you don't have time to go get one. If you don't know what to tell them on the phone, in other words, if you were going to tell the parts guy to bring you a bolt, I guess I've been waving around up here. What would you need to tell him? You want one just like this. One that's too short or too long won't work. Different thread size won't work. Different thread pitch won't work. You don't really care about the wrench size in most cases. What you gonna tell him? Exactly, the thread pitch, the length, and the actual bolt size, not the head size, right? Now, whenever I was putting a vehicle back together and working at the dealership, I always like to use a bolt just like the one that came in the car. Just a bolt that they brought out of the bolt bin. I didn't like that. I always want me to order. And you can tell them, they'll order you the exact bolt. And fender bolts and stuff. There was a guy that worked in a body shop named Tommy, and he always wanted exactly the bolt that went there. He didn't want one that would work. He wanted the one, when he put it back together, he wanted it to look like a factory job. You know what I mean? So, a bolt that's threaded into a casting is often called a what? That's sort of an interesting question, isn't it? A bolt that's threaded into a casting. Basically, they're talking about a cap screw. Now, what is a cap screw? What is a socket head cap screw? You ever heard of that? What do you turn a socket head cap screw with?
I'm guessing a socket.
An Allen wrench.
Wow.
Because the head of it, think about it now, Dalton, the head of it looks like a socket. Doesn't it? So you got to have something that's the reverse of that, so you can put that Allen wrench in there and bring it back out.
Gotcha.
Have you ever seen those Allen wrenches that are sort of made like a ball on the end?
Mhm.
What are they for?
Yeah.
Angle. If you want to go in there at an angle, you can turn it. In other words, if you can't get straight in there, simple as pie. You've seen extensions like that too, like a 3/8 extension, and the end of it looks sort of like diamond shaped, and that's so you can go in there at a little bit of an angle. And I have seen a situation where we were trying to take a motor mount bolt off that was really, really, really tight, couldn't get on it straight with nothing, and I had to take a regular extension to the grinder and make one that would wiggle so we could get it out of there. That tends to weaken it. And I broke a twisted off a snap-on extension one time pulling on a bolt real hard because it's a little bit weaker because of the shape of the extension and all that. I also bent a S-wing hammer into a horseshoe one time when I was trying to pull a nail out of some oak. And the guy at the lumber yard made it good. You know, he said it weren't guaranteed, but he said, "What did you do, put a cheater pipe on it?" And I said, "No, I just got mad." All right, the marks on the lines of the head of a bolt indicate what? Incidentally, 11, if you missed that, was supposed to be B. The marks or lines on the head of a bolt indicate what? Somebody talk to me now. I know somebody put some answers down there. What did you, huh?
Would be,
It's actually B or C, which would be tensile strength or grade, so you weren't totally off. Now, who got that right?
That was good.
Who got it right?
I
You get it
got it. I
right?
put a B too there.
Yeah. All right. Number 13, when working with hand tools,
You didn't mark it wrong, did you?
what do you do?
Is if you mark B on 12, is it wrong or halfway wrong?
If she marked it B or D?
Well, I marked it B.
You marked it B, that's.
I didn't mark both B and C. I
Yeah,
didn't
just
mark
put minus, put 0.5 or something like that, put half wrong or whatever you want to write down there. And you will be rewarded. All right, number 13, when working with hand tools, always,
Hey,
that is not, I'm sorry, that is not practical. Any person that has ever spent much time under the hood of a car will tell you
anyway.
there are
works.
times when you cannot pull the wrench. You just can't do it.
Anyway.
I mean, it's just, at this time you can't, you're gonna have to push it sometimes. But the problem with, if you've got a choice, you're a whole lot better. And I'm always telling you guys that it gets worth more to pull, you get the thing out. And make sure that the doggone wrench is always perfectly on there. One day, gosh, it was 2 or 3 semesters ago, I gave this young boy that, seemed pretty intelligent and all, and, I'm not saying he's not intelligent, but I gave him this oil change job on a Crown Victoria that was one of our cars that, belongs to the school here. And I says, change the oil on this Crown Victoria. And I looked over there while I was talking to somebody else, and he was under there, and I saw that he had a cheater pipe and that he was finished with it. And I was like, oh no, what did he do? So I went over there and says, what are you doing? And he was turning the oil drain plug bolt the wrong way to take it out. And he had cheater piped it to where it was just turning around and around. This is scary, isn't it? I mean, the ramifications are you could have to pull the oil pan off and replace it or something. Because I have actually seen oil pan that had to be replaced because you could not get the oil drain plug out. It would just go round, 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 and it would come out. Well, he stopped turning it to the right and started turning it to the left, and through some miracle it caught and it came out of there. Well, all we had to do is replace the drain plug because that nut in the pan is a lot harder than that drain plug. So secondly, on an oil change, the oil drain plug been in and out of there a lot of times, and bolts aren't really made for that. You know what I'm saying? Now you'll have less of that going on with a pipe plug than you will. What a pipe plug does, it makes the hole a little bigger because it's tapered. But an oil drain plug is going to have to be replaced periodically. Have you ever, and any of you guys that have done a lot of oil changes, you start taking the oil drain plug out and it breaks loose, and then you start trying to turn it and it gets hard. You ever seen that? If you see one that gets hard to pull out and you got to take it out the rest of the way with a wrench, you better replace that oil drain plug. Stop what you're doing, call the parts store and say, bring me an oil drain plug for whatever, 69, whatever. And they'll bring you one that's just exactly the right thread pitch and everything else, and you'll be able to screw it in with your fingers. The oil pan, unless it's aluminum, is going to be harder than the drain plug. You don't need to put an oversized plug in there because the plug you pulled out was stripped. That's just, when somebody does that, they mess everything up. But just remember that. And I've got a little bucket that's got a bunch of oil drain plugs in it we replaced because the threads were stretched a little bit. Here's something else. We're talking about bolts here now. You know how you like to zip them in and lug nuts on with impact wrench? Like that. And you say, well, I'll make sure this thing will come off. And you hit them really hard. Well, I have run into those situations where somebody had done that enough times to where they started screwing the threads up on one of the lugs or maybe two of them, and we go to take it off and it either seizes up and breaks off the stud, or it just turns around and around, won't come off. That's annoying as all get out, because here you are hoping to get something done quick and you got a big problem. And so that's why we set our impact wrenches on 2 instead of 4, and we zing, 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 zing one time, you know, to make sure they're all up with the impact wrench, and then we set it on the ground and we use a torque wrench and we torque it to what it's supposed to be. And sometimes the torque specs are kind of screwy. You know, the torque specs on this little Camry sitting out here is 76 foot-pounds. If you're hammering it with that impact wrench, you're liable to drive that thing up to 100, 110, 120. You know, because some of them impact wrenches are pretty strong. Just keep that totally on my, I mean, whenever there's a reason why you don't torque the lugs. Also, something else you can do if you want to be a belt and suspenders person, make sure that you keep your britches up. Take a little bit of grease and put on the threads and on that taper. Because whenever I was up there in Kansas City, I went to a class, and the name of the class was Students Break Things. You know what I mean? That was the name of the class. But what he was talking about was he had this little hydraulic chamber, and it was basically set up so he could put a bolt through that, because it was sealed around the outside and had a pressure gauge on it. And whenever he tightened the bolt to 35 foot-pounds, he could read the clamping force on that bolt. You get where I'm going? Had washers on it, had a nut on the back, bolt on the front, and the way that it was sealed and everything, when he tightened it up, that you could actually see how much pressure he was putting on that bolt. It was there for a reason. Okay, so he says, now watch this. So he puts the bolt on there, and whenever he torqued it up to 35 foot-pounds, and I'm going to think the clamping force on the bolt was like 38,000 pounds or something like that, which sounds like a heck of a lot. He says, okay, now we're going to get a brand new bolt, same everything, except we're going to put grease on the washer and under the nut and on the threads. We're going to grease it up really good. He says, and they tied it to 35 foot-pounds, and the clamping pressure went from 38 to 47,000 foot-pounds. I mean, pounds of pressure, PSI. And so what I'm getting at is, if you've got a little grease on there, you're going to have a whole lot better. You're not going to be dragging on this thing, and you're not going to have all the friction that's keeping you from doing what you're trying to do. And I never would have thought it would have made that much difference until I saw that gauge reading and hit on that thing right there. Anyway, the proper term for channel locks is what?
Multi-groove adjustable pliers.
Why are we calling them channel locks then? I'm not saying you're wrong. I'm just saying, why do we call them channel locks? Huh?
They have grooves.
No, we call them that because that's a brand name.
Is it really?
Yeah. The blue handles. You can actually get side cutters and all other kind of pliers that are channel lock brand. So if you see the word channel lock, people call them channel lock. What do you call a saw that like the carpenter uses? What do you call that?
Skill saw?
Skill saw is the brand name. It's a circular saw.
Yeah.
See what I'm saying? You call it a skill saw because that's what Granddaddy called it, and that's what everybody's called it, because skill saw was the most common brand. But everybody makes those darn things and all that. And also, you can put a metal cutting, an abrasive blade on one of those and cut just about anything with it. I mean, that's really handy in the shirt pocket. Let's see. The proper name for vice grips is locking pliers. And what's the benefit of vice grips?
Hold things in
They
place.
stay.
You can actually, you don't have to keep them held.
Yeah.
You can click. Now, over at Tractor Supply, and I think this is kind of silly, over at Tractor Supply, they've got some vice grips they've made, and the adjusting screw on the handle where you change the, is about it's a big old heavy piece of metal about that long. And it's made for using on the farm. And when you click that onto something, you got this big old long handle on it you can use to. Well, that's okay, but that's really a kind of a, with all due respect to Tractor Supply, it's a kind of a cheap pair of pliers, and if you ever try that, you'll bend that thing. I mean, where it goes in there, But I thought that was really cool. There's a lot of cool stuff at Tractor Supply, though, like my cell phone case, $5. You know what I'm saying? All right, now then, let's see, which tool list, oh, by the way, who was it that made vice grips? Who's the standard name for the people that make vice grips? You remember who the company is? It ain't Vice Grips. That was what they called them. Irwin made Vice Grips. There's a company called Irwin. And, but anyway, which tool listed as a brand name? Monkey wrench, side cutters, locking pliers, or Vice Grips? Well, see, that says D. Vice Grips is basically what they call that kind of pliers, but the Irwin makes them. Although there may have been a company before Irwin bought that called themselves Vice Grips, but Irwin was the company that made the Vice Grip. That's like channel locks. Channel locks are basically a brand name. Two technicians are discussing torque wrenches. Technician A says a torque wrench capable of tightening a fastener with more torque than a conventional breaker bar or ratchet. Is it? Can you put more torque on it with a torque wrench than you can a conventional breaker bar? No, you can't. Can you? Technician B says torque wrench should be calibrated regularly for accurate results. Who put B? Raise your hand if your person put B. All right then. So basically, that's B is the right way. That's 17. All right. What type of screwdriver should be used if there's very limited space above the head of the fastener?
The offset screwdriver.
Yeah, but I hate them darn things. Don't you hate them? I just despise them. I mean, there's a lot of little tools you can get from there. Now, all right. Now, y'all hang on a minute because I'm not done. I was going to say another thing. One of the things that you guys all need to be aware of if you're going to do this kind of thing. There's 250 cars for every service bay in the country. You know that? There's more cars in this country, more vehicles, I'll say, than there are licensed drivers. It's like, like, that's a heck of a lot of cars, isn't it? How many licensed drivers do you think there are? A lot of people that live in big cities, though, don't even own a car. Like if you live in Chicago or New York, you're likely not even to own a car. You know why you don't own a car if you're in one of the big cities?
Because you can walk all the places you can get there.
Costs, no, not really. It costs too much to park. I went to Chicago back in 2004, and I was up there. Of course, I met with the people that did the Motor Age magazine layout and all that. But I was while I was up there, I was up there to see my son graduate from Navy boot camp. Okay, so I went to park. I was on West Monroe Street, and I went looking for parking, and so I pulled into a parking garage, and they had me do. This valet took my car and went and parked it, and I had a little card with a claims check and all that stuff. And I was up there for 2 hours. I went up there and I talked to the people that worked the magazine, and we went and had a steak dinner. And when I went back to get my car up 2 hours later, it cost me something like $44 to get it out of hock. So if you're going to be driving in a big city, you better have a lot of money for parking. You know what I mean? Because that's why people use mass transit and all that. Furthermore, a lot of them doesn't build them. But next thing I was going to say too is that if you're going into this industry and you're going to learn how to do this kind of work and solve other problems, problems for other people, to begin with, if you like doing it, that'll be okay. You know what I mean? Of course, everybody, we're all told going through school that we can do whatever we want to, but whatever job you get needs to be one you'll like doing. If you don't like doing it, like for example, for 5 years I worked on diesels and big trucks and heavy equipment and hydraulics and all that kind of thing, and that was okay. And I worked, I've done that diesel work, the stuff they teach you at the bottom of the hill. I've done that stuff. And I'm not going to say I didn't make pretty decent money doing it, but I did just as well working on cars as I did working on the heavy equipment, the diesel. And so the long and the short of it is, if you don't like the job you're doing, you need to be doing something else. One of the people that I've got trained that does some of the best work and is really, really smart is a girl that graduated from here. Now she started out, in the Marines, and she was working on Humvees and stuff in Iraq and all. But she's really fast and smart, can troubleshoot, really, really sharp, and all that kind of thing. So it doesn't matter if you're a girl or you're a guy. If you can, if you put a lot into this, you're going to get a lot out of it. Something else I try to do when I finish up is I try to match people up with a job that I feel like will suit them. In other words, if you can't get along with your boss man, or you don't like the place where you work, you're just not going to do as well, right? Now, do you know why 85% of the people fail in their careers Is it because they're technically incompetent?
They can't get along with it.
Can't get along with other people? That's why